Okay, we'll give you a moment, Alex, to make sure you're ready. Rihanna, how are you doing? Great. Okay, so first thing to do is to measure out the zinc. In our calculation, or in my calculation, because we're using 0.1 mole per decimeter cubed copper sulfate solution, we know that the number of moles of copper sulfate is 2.5 times 10 to the minus 3, and we're planning to use a 4-fold excess of zinc, so we need 4 times as many moles of zinc, so that we're absolutely sure that the copper sulfate is in excess, and that gives us a mass of 0.65 grams. Ayan, when you're pipetting, you should ideally have a hand holding the pipette itself, but you don't want the pipette tip on the bottom of the solution. You shouldn't be resting, it should be suspended. Okay? Now that is a problem. Is that happening? Yeah. What you can do is if you, right, this is a bit tricky, but if you slip it off and put your thumb over the end, roll it back down again, and as quick as you can, you're going to lose a little bit, but I need to report that to technicians because that's happening. Not ideal. I'm going to have that problem too. Okay, so the first thing I'm going to do, people at home, is I'm going to weigh out my 0.65 grams of zinc. Not sure how to say. Now I don't need the exact amount. I don't need the exact amount because it's a large excess anyway. So I've got about 0.67 grams there. So that's fine. Sticking to the weighing boat a little bit, so I know not all of that is going to end up being added, but again, it doesn't matter because it's a 4-fold excess. So next up, the fun bit, I need to pipette my copper sulfate solution. So we're going for 25 centimeters cubed of our 0.1 mole of copper sulfate. I'm led to believe from the other people in the group that pipetting is going to be a challenge. I don't know why they didn't give us the bulby one. My pipette had nuts up. Okay, so I'm just making sure, I'm adjusting it just to make sure that the meniscus is exactly sitting on the line. It's been a while since Harry used pipette. transfer that to my cup. Allow it to empty under gravity. So as when I do my titration, I'm going to touch the tip of my pipette to the surface of the liquid, draw out that last little bit. And make sure that I place my pipette somewhere I can get a hold of the desk, look back on the copper sulfate. So I have my 25 centimetres cubed of 0.1 mole copper sulfate solution. I'm going to place that carefully inside my beaker. And now I'm going to get set up, my thermometer set up, ready to start practical. So you need to go through the lid. And my thumb's going to need to be a little bit lower here. So I want the bulb of my thermometer in the centre here of my solution. Now I can read my thermometer to hand. The thermometer just needs to be clamped sufficient so that it's held at the correct height and it's not going to topple. And I can read my reading. And I'm going to need to, when I come to it, I'm going to need to empty the zinc through the lid there. So I just need to be kept confident that I'm going to be all right to do that at the exact correct time in my practical. So, everything is set up. People at home, are we ready? Great. Okay. So, I don't think I'm going to be able to get I'm just going to bring the camera around to show you what I've got here. So, I've got my zinc down there, ready to go. I've got my stopcock ready to go. And here's my thermometer. And I've turned it around. I don't know, you probably can't see that because the cameras aren't brilliant. But I can read the scale on there quite nicely. It's a very precise thermometer. It measures to the nearest 0.2 of a degree. So we'll be able to get nice, accurate, precise temperature readings. Just leave it somewhere it's not going to fall on the floor. Okay. So I think I'm ready to go. My drink's ready. That out of the way. This out of the way as well. Stopcock ready. Okay. So see this. Okay. So ready to start. So I'm going to stop, and I need to, every 30 seconds, I need to call out a reading for you. So I will call them out for you as it's going along, listening carefully. So the first reading is 23.6 degrees. Wow, warm in here. People in the room, make sure you're confident reading the thermometer before you start. It's a very fiddly scale. So 30 seconds, 23.6 degrees again. They're coming up to 1 minute now. Ready? 23.6 degrees again. Right, I'm doing my reading, so go on. You can stir it by moving the speaker. So So 1 minute 30, again 23.6 degrees. Again, 23.6 degrees. And 2.5 minutes, this is going to be my last reading before I add the zinc. It's coming up now, 23.6 degrees again. So now I'm going to get ready, add my zinc. So I need to do it exactly 3 minutes. Okay, so I've added that, and I need to give it a stir. I don't need to take another reading now until 3 minutes 30, so I've given it a good stir there. Put the lid down. Well, and then at 3 minutes 30, I'm going to be reading the temperature again. That's 26.0. 26.0. And we'll give it another bit of stir. Coming up to 4 minutes now. .0. 3 minutes, Alex, because I was adding my zinc, so we don't take a reading while we add the zinc. The next one is 27.4. It's 27.6 for 5 minutes. It's 27.6 again for 5.5 minutes. .6 again. 27.8. Still going up slightly. So you see the temperature rise for this. Oh, sorry. It's going a little bit slower. It's still going up now, 3 minutes in. $28.0. Guys, when you're doing your practical, once you've added the zinc, make sure you do a little kind of swirl between each reading, because I'm finding that reaction is 28.4. I'm not sure my results are going to be very brilliant. 28.4 people at home, still going up. Get ready, yeah. You see I'm swirling without lifting. I'm just giving it a swirl on the floor, on the ground, as it were. 28.6. No, it's not going to go very high. Next time we'll use more concentrated sulfate, I think. Okay. 28.6 again. Yes. We can go through the readings at the end, people at home, don't worry. $28.6. So that was 9 minutes, 28.6. $28.6. $28.6. So it looks like our temperature rise here is only going to be quite low, about 5 degrees, which is less than ideal. We want really quite a large temperature rise so that we can get faster cooling, which will give us more precise results. The next time I do this practical, I'm going to ask for more concentrated copper sulfate solution. Perhaps 0.2 molar. 28.8. Now the other thing, when you're doing this practical, actually I'll talk after I've done my next reading. Just coming up. 28.8 again. The other thing to consider when you're doing this practical is that you want your graph to have a decline at the end. So maybe you need to do it for longer if it's taking you a while to get to the point where the temperature starts to go down. You want a good 7 or 8 readings of temperature going down so you can get a good line of best fit. It will go up then down as it starts to cool. And you want at least 7 or 8 readings of going down so you can do a good line of best fit. So 12 minutes, got 28.6. So mine's on 12 minutes. It hasn't really, sorry, 28.8 again, sorry, people at home. And it hasn't started to go down yet, so I've been here a while. So. Yeah. Well, mine went up for almost 10 minutes. The other thing is, well, when I've done my next reading, I'll talk again. 28.7, I think. That's 12.5 minutes, people at home. I'm going to need more space on my results table. These are the ones. You don't need to go down. It's got to be on the decline. 28.7. That's 13 minutes, people at home. I'm at 13.5. There we go, 13.5 next. Now, ladies and gents, if this is my chemistry project, 28.6 for 13.5 people at home. If this is my chemistry project, I would be thinking now, I need a bigger concentration of sulfates to get good readings for this. So we can't do that today because this is what we've got. But if this is my chemistry project, that's what I'd be thinking. I'd be thinking, next time I'm going to do it again, and I'm going to use a higher concentration of copper sulfate so I can get decent results. Because our decline is going to mean our results, because it's quite small, it's going to mean our results are not very precise. And I'm also thinking as I go along, definitely need to keep taking readings because it's still only 28.6, it's only just starting to go down. I want to have a nice, smooth, straight line down to draw my line. So I need to keep going until I've got enough readings. Ideally, you want a temperature rise of maybe 15, 20 degrees so that you get a good rate of cooling. I know. So our results are not really great, but we can still use them. Oh, 2.5. 28.6. Minutes. 28.6. So 15.5 minutes. 28.5. Sorry? Still got? Yeah, so mine rose at 10 minutes. Or it didn't start going down until after 10 minutes. Yeah, that's, remember you added it at 3, so that's. Yeah. $16 minutes. 28.4. So 16.5 minutes, 28.4 again. Yeah, it will be for a little while, and then it will eventually start going down. It won't hurt to mix it. 17 minutes, 28.3. So we've been declining now since 15 minutes, really. So we'll take maybe another 3 or 4 readings, then we should have enough for our graph. .3 again. That was 17.5 minutes. I reckon we'll go all the way to 20. Why not? Nice round number. .28.2. It's going down. It's going down by about 0.1 every minute. Eighteen and a half. 28.2 again. Until you've got about at least 7 or 8 for your graph. So once it's obviously started to go down, you're going to need another 7 or 8 readings. 28.1 for 19 minutes. .28.0. One more reading, people at home. .28.0 again for the last one, people at home. So that was 20 minutes. Okay, so during that experiment, hopefully you've picked up on some of the kind of the more A-level type ideas there, that actually, if this was my project, I would be doing another experiment now. I would be making a new solution of copper sulfate, which was probably 0.2 molar, or maybe 0.25 molar. I want it more concentrated, so that in the same volume, I can have a larger number of moles. If you increase the volume, then there's more room to share the energy out between. So again, your temperature rise will be lower. Ways you can make your temperature rise larger is by decreasing the volume, or by increasing the concentration, so you've got more moles for your reaction. However, we don't obviously have time to make a new solution today, so we are going to use this for our graph, to practice drawing our graph. The other thing to bear in mind is that with this type of experiment, you need to be kind of thinking as you go along, have I got enough results for my graph? So originally I thought we were going to monitor for 13 minutes, but it was clear that the temperature hadn't started to go down reliably by then. So we're looking until the temperature starts to decrease steadily, and then after that we're going to need at least 7 or 8 points for a really good line of best fit. Did you need me to go through the temperatures? People like, I'll put that in the chat. Are you okay? Do you want to check any of them or only you meant? Okay, great. So the next step is to plot the graph. So there's an example graph on the worksheet. When you're plotting your graph, the bigger the scale that you can use, the more accurate your readings are going to be. So you need a good, you want to use as large a scale as you can for the y-axis. You see, you do not need to start at 0, you can cut through and start just below your starting temperature. So you can start your graph at 23 degrees, your maximum is 29. So you just need a scale that goes from 23 to 29, taking up as much space as possible. Now, because our temperature rise is quite low, our results are not going to be very precise anyway, and it's going to be tricky to draw the accurate line of best fit as well, because of the we're reading to the nearest 0.1. We've got a lot of repeated readings in here, and the repeated readings mean that your line of best fit is going to be trickier to draw, because by definition, the line is not going to be able to go through any of the points. Okay? So those are points to bear in mind, and reasons why, ideally in this type of experiment, you want a larger temperature rise, so you have a faster rate of cooling, and you have a more precise estimation of the maximum temperature rise. So you need to find yourself, ideally, graph paper. If you don't have graph paper, you can print some off the internet. You've got a printer. If you don't have graph paper or a printer, then if you can find some squared paper, that would be great. And we want to plot as accurately as we can that graph. And then one left go happen. Oh, yay! It will still be decreasing. You just need enough decreasing points, so maybe 7, 8, or 9 points after it starts to obviously go down, so that you can draw a good line around it. Okay? So we have 20 minutes, didn't we?
So you need to obviously have space for all of your minutes. So you need to plan out, part of the skill of drawing a graph is to be able to plan out so that your scale takes up as much of the space as possible. So I'm doing it on the screen on my visualizer. Because why not A? See if I can focus that a bit better. I think it's about right before. So I've gone for I'm doing it landscape because we've only got to go from 23 to 29 degrees up the side, and we've got a lot of minutes. So I've gone for landscape, and I'm using a centimetre for each minute because I've gone up to 20 minutes. So along the bottom we have time in minutes. Now, okay. So these super duper visualizers they've brought us don't get far enough away to fit in the whole paper, or we just about fit it in there. There we go. When you're plotting your points on the graph, remember you didn't take a reading at 3. It's easy to get into the kind of the rhythm of plotting your graph and just going along in even instalments. But remember, there will be no reading at all at 3. So 3.5, I got 26. 24, 25, 26. 4, I got 27. .5, 27.4. So I had an issue with stirring in my practical. Because we had 3 readers at 27.6, and then I gave it a good old swirl, and we had another increase, which is slightly annoying. Another reason why, if this was my chemistry project, I would definitely be doing it again. Oh, that's in the wrong place as well. Where's the rubber? Yes. I'm not really that far away, but wait. So where were we? 20. So 4.5 was 27.4. And 27.6. And I had 3 readings at 27.6. I don't know what time it is. 10:05. Got 25 minutes. 27.8 for 6.5. So that is there. 28. 7 minutes. 28.4. 7.5 minutes. 8 minutes. 28.6. 8.5 minutes. 28.6. I've got 1, 2, 3, 4, 5. 28.6 is 1, 2, 3, 4, 5. And then 1, 2, 3, 4. 28.8. And I got 1, 2, 28.7s. 4 28.6s. And 28.5. Okay, what a lovely graph. You're right then, Leah. Yeah. So they're really, you saw I made a mistake with mine, they're really fiddly to plot, takes a little bit of practice, that's why it's a good idea to go through. And as with anything in science, if you're not happy with stuff, you do it again. So as I said, we only obviously have the chemicals to do this one and the time to do this once through today, but if you were being a chemist, you would say, I don't like that temperature rise, I'm not going to get very good results. I'm going to make a new solution, do it with more concentrated solution. Also, I would do mine again because quite clearly you can see from mine, I hadn't stirred it properly because it stopped for a bit and then I gave it a swirl and it went up a bit more. So I obviously didn't mix mine properly at the beginning. So another reason why this I would do again. If this is my required practical, I'd do it again as well. But this is just our practice run, so I'm not too worried. I just want to practice the techniques today. Okay? So once you've got your graph, you need to draw your lines of best fit. So along the bottom, it's a line. So we have a straight line here, which we extrapolate to 3 minutes. And then we ignore all the going up stuff, and we just look at the going down stuff. So this is the area I'm interested in of my curve. I'm ignoring all this because that's while the temperature was still increasing. There was still some of the reaction was going on. Okay. What we want to estimate is the rate of cooling. So the cooling part is this part here. So I want a line of best fit through these points, which because we're reading to the nearest 0.1, it's jiggity. That's not really a scientific term, but it's going to be tricky to draw a good line of best fit. I'm going to give it my best shot. I reckon it's probably something like that. And so once I've got my line, I'm going to extrapolate it all the way back to 3 minutes. Okay? So then I find 3 minutes on my graph, and I draw a nice vertical line. I might have done this before, but I'm doing it now. Now you see that something to bear in mind for the future, that my line of best fit goes above where I plotted my axes to, because obviously you're going backwards, you're heading above your highest reading on your thing. So that's something worth bearing in mind when you plot your graph for real. Obviously, if you ran out of graph paper because you've gone right to the top, you think, okay, I've got to plot my graph again then. Bit of a pain, but I'll do it because in science we like to do things right. Okay? But I'm okay, mine stayed on the graph paper. So I can just extend my axes quite nice and easily, 29.5 there, 30.0 there. Hello.
You teach us break?
I've got a live lesson. I can be in and out.
I just need a quick 3-4 minute chat with you.
Look at this visualizer.
I just saw that, yes.
It's not very good because you can't actually get the whole paper in. You can't if it's portrait.
You clamp it a bit higher up.
Well, yeah.
You've got the clamp.
But yeah, and we're on a live lesson as well. We've got the camera going too. You can wave to the pupils at home.
Yeah.
Give them a wave, you're on the shot, sir.
There's no mice in there, right?
No mice. No, we've been doing a very important science.
Yeah, what you
This stuff, blue stuff and metal stuff.
Okay.
No, not that. This is chemistry, you don't deal in living stuff.
Yeah, like E.T., that's still E.T. where they've got all the mice that running around the side of them.
So, did you want me to come over and break or something? Right. So then, the final stage, once you've got your beautiful graph, mine's off the visualizer again, there we go. You measure delta H. So I'm going to draw it in as an arrow. Or delta T. Delta T. So, I've got 12.2 centimetres. So each centimetre is half of a degree. So that's 6.1. I want to get it higher, keep the whole thing out. What did we say it was? 2.5 times 10 to the minus 3 moles of no, I'm not going to say that. I'm going to say between 25 centimetres cubed of 0.1 molar CuSO4 excess zinc. Right, people at home, hopefully you've managed to, well, you are in the process maybe of drawing a graph. Hopefully you can see on my screen share the beautiful graph that I've just constructed as an example. If there's any questions about how to draw your graph. No, that's good. So you need to identify the decline period, draw a line of best fit through the bit where it slopes down. A line of best fit through that, backwards as far as 3 minutes, and then a line of best fit through the starting point. So you're going to have to slope down there because yours is cooling down. Yeah, so yours won't be horizontal like mine, it will be sloped down slightly. And then then you draw your line up at 3 minutes and you measure where the distance between two lines at 3 minutes. Yeah,